Good morning students, welcome to Sri Guru online classes. In the last class we discussed the mechanical properties of solids, spring ball model, stress and strain. In the today class I am going to discuss the application of stress and strain, and Hooke's law states that on the basis of stress and strain, what is the Hooke's law means? Hooke's law states that within the elastic limit, stress is directly proportional to strain. What is that elastic limit? Elastic limit means, in the last class we discussed elasticity, plasticity. When an object is immersed in a liquid, liquid also exerts a force. The force acting by that liquid to compress or decrease in volume means that the initially certain volume, because of that water, the force is acting in all the direction, the volume of that particular solid body is going to decrease. Why it is going to decrease means a deforming force is acting. Similarly, consider length, a particular length is going to decrease or increase. The increasing length because of deforming force that regains its original shape. That regaining capacity is due to the restoring force. If the restoring force is more elastic. If the restoring force is less elastic. But within this elastic limit, the property of a body by virtue of which it regains its original states or original shape or original configuration. What is this elastic limit? At a particular limit, let us consider a spring. Initially we applied a 5 Newton. Force applied is 5 Newton. Initially it is at rest. Initially it is at equilibrium. After applying 5 Newton, the length of the spring is increased. Now I am going to increase the force. Here I applied a force is 10 Newton. Force it applies is 10 Newton. Here it is at rest or at equilibrium. Now here force is 5 Newton. Now here force is 10 Newton. Again we applied a certain force. Let us consider 100 Newton. Let us consider 100 Newton. We are increasing force continuously. The property of elasticity goes on increasing. But at a particular instant, the body regains its original shape or size. Behind that point, the body does not regain its original shape or size. That point we called as elastic limit. Elastic limit means at that particular point, the body which is going to regain its original shape or size. At a particular point means the maximum stress applied by a maximum stress is applied on a solid body, the body which regains its original shape or size after removal of the deforming force. That point we called as elastic limit. The elastic limit. If suppose behind that elastic limit the body is going to extend, stretched, but this is not going to regain. Now this is elastic nature, this is also elastic nature, this is also elastic nature, but elasticity goes on decreasing. Decreasing means which is going to convert from elastic to plastic. This is elastic limit. But the statement of Hooke's law is within the elastic limit, stress is directly proportional to strain. On this particular limit, stress is directly proportional to strain. Behind this limit, Hooke's law is not going to applicable. Those type of material we called as elastomers. Even though these material initially elastic property, but according to Hooke's law, within the elastic limit, the stress is directly proportional to strain, but elastomers means which does not obey Hooke's law. Even these materials are elastic in nature, but these type of materials does not obey Hooke's law. Why? Because within this limit, the stress is not going to equal to strain, or it is not directly proportional to strain. Here again we should convert in the form equal form. The proportionality should remove, that is stress is equal to K into strain. What is this K? K is Hooke's constant, and also called as modulus of elasticity. What is Hooke's law? Within the elastic limit, stress is directly proportional to strain. Even some materials is there, those elastic properties, but they does not obey Hooke's law. In this elastomers materials, let us consider a rubber. Rubber is also stretching property, but which is not regains completely. Little bit of amount is decreasing or increasing in its length as compared to original. Okay, the elastomer is the material which does not obey the Hooke's law. The statement of Hooke's law is within the elastic limit, stress is directly proportional to strain. Now this K is called as modulus of elasticity, that is the continuation part of stress and strain. In the last class we discussed the stress strain. What is stress? The force acting per unit area. What type of force? Means restoring force. The restoring force is acting on a particular area of cross section, that we called as a stress. In the stress is three types. One is longitudinal, only we are considering the length. Another one is tangential. Tangential means only we are considering the shape or size. But in the third type, we are complete discussion of solid bodies, that is called as volumetric stress. This object is going to immerse in a liquid. That liquid exerts a force in all the direction. Because of that force, this volume is going to decrease. This already we discussed in the last class. Today I am going to discuss the complete very important part in this elasticity chapter, that is modulus of elasticity. Modulus of elasticity. Okay. Modulus of elasticity means already we got the definition. K is equal to, we are represented this modulus of elasticity in the form of K. Okay, what is the modulus of elasticity now? K is equal to stress by strain. K is equal to stress by strain. Modulus of elasticity is defined as it is the ratio of stress to the strain. What is the SI unit for this modulus of elasticity? SI unit of modulus of elasticity is, stress unit is Newton per meter square and strain no unit. This is the SI unit for modulus of elasticity, and also dimensional formula m L raised to minus 1 T raised to minus 2. Already we know that this is the dimensional formula for all type of stress. Keep in your mind, in this chapter the SI unit is same for stress as well as modulus of elasticity. In this modulus of elasticity, these modulus of elasticity are fixed with respect to a different materials. Steel, its modulus of elasticity is 2.0 into 10 to the power of 8 or 10. We are considering modulus of elasticity of steel is approximately in the power form 10 to the power of 10 Newton per meter square. Approximately we are considering. And these modulus of elasticity is depends on stress applied and how much strain gained by that objects or materials or a certain matter. And modulus of elasticity is also 3 types. That first one is Young's modulus. Young's modulus. What is this Young's modulus? Young's modulus is defined as, it is denoted as capital Y. Young's modulus is defined as Y is equal to longitudinal stress by longitudinal strain. Longitudinal strain. Listen here. What is the definition of modulus of elasticity? Stress by strain. Young's means we are completely discussing about the length. We are discussing completely here length only. Length means longitudinal. Longitudinal stress by longitudinal strain. Stress by strain. Which type of stress? Longitudinal. Which type of strain? Longitudinal strain. We know that already. What is the formula for stress? Force acting per unit area. And what is the unit of strain? Delta L by L. Already we know that the formula for longitudinal strain. Now this implies FL by A into delta L. This is the important formula for Young's modulus. In this Young's modulus, we are discussing completely the changes of length, that may be normal changes or that may be along the direction of applied force. The length may increase. Already we know that. These diagrams already we discussed in the last stress and strain bit. If the length increases along the direction of applied force, we call as tensile stress. And if the length is decreases along the direction of applied force, this is called as compressive stress. Compressive stress, already we discussed these things. The Young's modulus also we are discussing the length property of a solid. Completely we are discussing about the length only. That may be normal force is acting on a solid body that maybe perpendicular force is acting on a solid body, and these solid bodies Young's modulus is fixed. Only here we are discussing about the change in length. What is change in length? That is delta L, which is equal to FL by A into Y. Here force acting per unit area. Force, we are acting a certain force, that may be 5 Newton, 10 Newton, 100 Newton, that is fixed, and also initial length is also fixed, and this area of cross section is not going to change. Already we discussed in the last class. The volume is not going to change, only the length is going to change. Why? Because if the length increases, diameter decreases. If length decreases, diameter increases. Already we discussed these things in the last class. F is fixed, L is fixed, area is also fixed, and Young's modulus of a particular substance is also fixed. We should find the delta L. We are going to find the change in length of a particular solid by using this formula. 2020 KCET, the past CET, they asked which type of material has Young's modulus, or Young's modulus of a rigid body is. Young's modulus of a rigid body is. Young's modulus of a rigid body is. In the options, that is unity, second option is infinity, third one is between infinity and 0, and the last one is 0. Listen here. The Young's modulus of a rigid body is, perfect rigid body is. They asked perfect rigid body is KCET 2020. Past KCET 2020, they asked Young's modulus of a perfect rigid body is. They mentioned first option is unity, second option is infinity, third option is between infinity and 0, and fourth option is 0. Listen here, we got the relation delta L is equal to FL by A into Y. What is the definition for Young's modulus? Longitudinal stress by longitudinal strain. Listen here. Perfect rigid body means which is not going to change by applying a certain stress. Listen here, we can apply a stress on this chalk. This chalk penetrates certain force. That force not going to cause, or this stress we applied on this chalk, that is not going to convert as strain. We applied a stress, but which is not going to gain a strain. This type of material we call as perfect rigid body, which is not going to change its shape or size after applying a force. That force we call as a deforming force. Means that perfect rigid body we can apply a stress, but that body is not gains a strain. Not gains a strain means, what is the definition for Young's modulus? Young's modulus is stress by strain. What type of stress? Longitudinal stress. What type of strain? Longitudinal strain. There is no change in the length. There is no change in the length. But we applied a stress. Definitely we applied a certain stress. Certain force is acting on a per unit area of cross section. This is a rigid body. We applied a certain stress. But this shock doesn't gain a certain strain. Means no strain on this chalk. No strain means Just to consider 0. 0 by something, something by 0. What happens? Young's modulus is infinity. Young's modulus is infinity. We can say the answer is infinity. Past KCET 2020, very important concept. Young's modulus of rigid body is unity, infinity, between infinity and 0 and 0. We know that the concept longitudinal stress by longitudinal strain, definitely that body does not gain any type of strain. Strain is 0 means something by 0 is infinity. Okay, this is clear, I think so. This is the first type of modulus. Let us discuss the second type, modulus of elasticity. Second modulus of elasticity. This is also important. They may ask this year. Second one is bulk modulus. Bulk modulus. What is modulus? Stress by strain. Bulk means here we are discussing volume. Engs means length. Bulk means volume. Just to consider any symbol. Bulk modulus volumetric means just to considering as V. Okay. Or you just to consider first alphabet, that is B. Bulk modulus, which is equal to what I have stress here. Young's modulus means longitudinal stress. Here we are discussing about the length. Here is volume. Volume means which type of stress? That is volumetric stress. Volumetric stress by volumetric strain. Volumetric strain. Volumetric stress means, definitely we know that stress means force acting per unit area. Force acting per unit area. By volumetric strain means change in volume by original volume. This we can also write Fv by A into delta V. This concept we can use in next chapters, those kinetic theory of gases. In that we can use in the Boyle's law also, gaseous law also we are using this concept. The very important bulk modulus is volumetric stress by volumetric strain. Volumetric stress by volumetric strain. The formula is very important. We know that already. What is pressure? Pressure is equal to force acting per unit area. We can consider here P by A. Bulk modulus, which is equal to PV by delta V. We can use this formula to solve a numerical on the basis of gaseous laws. And this bulk modulus, which state of matter means this bulk modulus is obey for solids as well as liquids as well as gaseous. Which state of matter is going to explain by bulk modulus? That may explain solid bodies, liquid bodies and gaseous. The bulk modulus is more for solid bodies. As compared to solid, liquid is less. As compared to gases, liquid is more. Okay, these we can discuss later in the upcoming chapters. Those are gaseous laws. or in the second chapter of part 2, that is mechanical properties of fluids. We are discussing these two things in fluids. Okay, this is second law. In the second law we are discussing about the complete volume. This is our initial volume. We applied a force in all the direction. When an object is immersed in a liquid, that liquid also exerts a force. Because of that force, this volume is going to decrease. This is the change in volume, this is the original volume. We can also say that this volume is compressed. Volume is compressed. Compressed means in all the direction the force is acting. Because of that force, it is going to compress. In all the way we are applying a force, this volume is going to compressed. This compressibility of a solid body is inversely proportional to bulk modulus. Very important. Always keep in your mind, compressibility of a solid body is always inversely proportional to bulk modulus. See here, compressibility, change in volume is inversely proportional to bulk modulus. Inversely proportional to bulk modulus. Compressibility means change in volume is inversely proportional to bulk modulus. Compressibility is inversely proportional to bulk modulus. This we discussed in the bulk modulus. The Young's modulus, we are discussing only length. That's why the Young's modulus is purely explains the solid properties. Bulk modulus explains solids, liquids as well as gases. And third property is third law or third type of modulus is, that is rigidity modulus. I think so you all know. Young's means we discussed about the length, bulk means we discussed about the volume. Definitely rigidity means we discussed about the tangential or shearing stress. The rigidity modulus is defined as, it is denoted by neta, and here we discussed the shape, size. Rigidity modulus is defined as, it is the ratio of shear stress, or we can also say that tangential stress by shear strain, tangential stress by tangential strain, or shear stress by shear strain is known as rigidity modulus. Stress means force acting per unit area. Strain means, already we got that theta angle tilt, that is theta, or we can also write F by A. This angle, we know that already, this is fixed with respect to a surface. We applied a parallel force on these bodies. Because of this parallel force, this shape is changed or size is changed. The angle tilt, here the change is delta L with respect to, we can consider this is the length, or we can also consider this is height. Change in length with respect to a particular height, that is theta, that is delta L by H. We can also write F H by A into delta L, neta, which is equal to Fh by A into delta L. Here also we are discussing only solid bodies. Rigidity modulus is also explain the state of matter, means definitely that is solid only, and it is not possible to apply this rigidity modulus for liquids or gases, only it is applicable for solid materials. What is the formula for shear modulus? That is FH by A into delta L. In some of the books they are considering length also. You can, that is, we considering this is the height means just you considering as H, or you considering this is the length of a solid bodies, just you considering L. And these three types are very important. They may ask in the 5 marks, state and explain modulus of elasticity. What is modulus of elasticity? Stress by strain. What is Young's modulus? Longitudinal stress by longitudinal strain. What is bulk modulus? Volumetric stress by volumetric strain. What is rigidity modulus? Shear stress by shear strain. And these formulas are very important. You should keep in your mind. And this is about modulus of elasticity. Let us glance these all three in one table form. In one frame we discuss these all things in one table form, and it is very helpful us to solve a numerical or solve a CET questions, and it is very easy to understand the concept of stress, strain and Young's modulus, and these three depends on each Listen here. First we discussed about the stress. What is stress? This is force acting per unit area. What type force? Restoring force. Restoring force. Here the types of force means, that is, first one is longitudinal stress. Longitudinal stress. Second one is tangential or shearing strain or shear strain. Third one is volumetric or we can also say that volume stress. And the strain, what is strain? That is change in dimension by original dimension change in dimension by original dimension. Here is also three types. The first one is longitudinal strain, and second one is tangential or shearing strain, and third one is volumetric strain or volume strain. And today class we discussed about the modulus of elasticity, or sometimes they call as modulus of elasticity. In some of the examination they only ask moduli. Modulus of elasticity means stress by strain. In that first one is Young's modulus. What is Young's modulus? Longitudinal stress by longitudinal strain. longitudinal stress by longitudinal strain okay. Second type of modulus of elasticity, that is tangential or shear stress, means rigidity modulus. Rigidity modulus is defined as shear stress by shear strain or tangential stress by tangential strain. Shear stress by shear strain. And third one, that is bulk modulus. That is volumetric stress by volumetric strain. Volumetric stress by volumetric strain. Volumetric stress by volumetric strain. Listen here, and this chart will help us to find modulus of elasticity by stress and strain. If we know stress and strain, we can explain the modulus of elasticity, or we can remember very easily. Longitudinal stress by longitudinal strain is Young's modulus. Tangential stress by tangential strain is rigidity modulus, and volume stress by volume strain is bulk modulus. Already we know that the SI unit of stress is Newton per meter square. Here is no unit, and here stress by strain, stress unit is Newton per meter square, and strain is no unit. It is nothing but a number. Something by number, something by 1 is, that is same, that is Newton per meter square only. Here longitudinal stress means we are discussing about the length and only solid bodies. Only solid bodies. That may be here force is applied normally over the surface of a body. The force acting on a surface of a body is normally, or the force is acting perpendicularly over the surface of a body. The force applied along the direction of applied force, the length is going to change. The length is going to change, this much of length is going to change, that is delta L. Along the direction of applied force, that is the length is going to decrease. The decrease in length, that is L minus delta L. Initially this much of length, L minus delta L. We applied a force perpendicular to the surface of a body. The force may be perpendicular, the force may be normal. We are discussing about the change in length. If the increase in length we call as tensile, if decrease in length we call as compressive. Similarly here is also, we applied a stress on a solid body, definitely that body gains a strain. Strain means change in length, that may be decrease in length or that may be increase in length. Here we applied forces normally over a surface of a body. The body's shape is going to change, the length is going to change. The body gains a particular amount of strain. Because of that strain only the length is going to increase, L plus delta L. The length increases, and here the length decreases. Length decreases. Why? Because here is force is applied perpendicular over the surface of a body. Along the direction of applied force, the length decreases, that we call as compressive strain. Tensile, compressive, and here also we discussed about the length only, and here we not discussed about the volume. Why? Because if the length increases, volume decreases. Length decreases, volume increases. the volume of that particular solid body not going to change, only the length property is going to change. This we discussed here in the modulus of elasticity. What is the longitudinal stress formula? That is F by A, force acting per unit area. Here we applied a force that may be normal, that may be perpendicular over the surface of a body. That force acting per unit area, force acting per unit area, and change in length by original length, change in dimension. Dimension means we are considering about the length, that is delta L by L. This is change in dimension. Dimension means length. Change in length by original length, that we call as delta L by L. This is FL by A into delta L. The SI unit is same. Similarly, in the tangential, we discussed the solid body is fixed to the surface. We applied a certain force. Angle is tilt. This much of change in length with respect to this is the original length, or in the some of the books they are considering as a height. We can say that theta, that is tan theta, which is equal to opposite by adjacent, that we considering as delta L by L, or we can also considering H or delta L by H also. If you considering height means just you considering H, or you considering length means, here we discussed about the shape, the change in shape. Here the stress applied, the stress causes the strain. Here also we discussed about this nature. Here is angled form theta. That theta is called as change in angle or angle tilt. The theta is equal to change in length with respect to original length. This much of length is going to change. This is our original length L, or already we know that we can also considering as H. Okay. Tangential stress by tangential strain. What is tangential stress formula? What is tangential stress formula? Stress is force acting per unit area. What type of force? Parallel force is acting. Force acting per unit area. Parallel force. Sorry, here don't mention the strain property. Here force applied is parallelly over the surface of a body. Because of that parallel force, the body is going to tilt. Force applied per unit area, just be considering here shear stress means force acting per unit area. Strain means definitely that is also, or just to considering once again. Now second one, that is tangential stress. Here is also force is acting on a particular solid body. The force acting parallel over the surface of a body. Because of this force, the body shape is going to change. Here force applied is parallel over the surface of a body. Force acting per unit area. We can say that this is the tangential stress. Because of this stress, the body strained. The shape of that body is going to change with respect to a certain angle. Angle is tilt. Here is this much of length is changed, that is delta L, and here is original length, that is L, or you considering H also. What is strain formula? Change in dimension by original dimension. Change in dimension here means shape is going to change. That is tan theta, which is equal to shape means what is the change? That is opposite by adjacent. Opposite means that is delta L by adjacent means length, that is L, or you can also considering delta L by H also. Sometimes we considering H also. Just you write here. What is tangential stress? Here also force is acting per unit area. Force acting per unit area. What type of force? Parallel force is acting. divided by what is strain? That is delta L by L or delta L by H. We can write FL by A into delta L. Listen here. Young's modulus and rigidity modulus, same formula. Why? Because these two types explains only solid bodies. We can apply this formula for solid bodies, not for liquids and gases. Now come to the last one, that is volumetric stress. When an object is immersed in a liquid also exerts a force. Because of that force, the volume is going to compressed. Compressed means the volume is going to change. Initial volume is V, change in volume is delta V. Because of this force is acting in all the direction. Force acting per unit area. Here also force is acting per unit area in all the directions. Because of that force, the body is going to strain. This is our initial volume. The volume is going to change. Why? Because here is force acting in all the direction. This is the change in volume with respect to original volume. What is the definition of strain? Change in dimension by original dimension. Change in dimension means here we considering about the volume. Change in volume by original volume. Just consider these two and mention the formula for bulk modulus. What is volumetric stress? That is force acting per unit area. And what is volumetric strain? That is delta V by V. Finally, FV by A into delta. We can convert this formula in the form of pressure also. And these are very important, compulsory one question in CET, compulsory one question in JEE as well as NEET. In the theory also, these three are very important. Always keep in your mind stress, strain and modulus of elasticity. Modulus of elasticity depends on stress as well as strain. Hooke's law states that within the elastic limit, stress is directly proportional to strain. If the stress is not directly proportional to strain, we can't find the moduli. We can't find the moduli. Up to this, we discussed in this today class. In the next class, I am going to explain the stress strain curve with the different materials. Thank you.